Continuing our discussion with continuity. So now we're going to focus on where a function is not continuous. And this is going to be somewhat easy. You can look back at the definition and just show that one of those conditions, one of those three conditions does not apply. But there's easier ways to do that, and that's what we're going to go over here. So first of all, a discontinuity is just where a graph isn't continuous. So like if you look at this function right here, this graph would have a discontinuity at x equals 1. Now we're going to distinguish as to what type of discontinuity that is. So I think to summarize this before we actually go over it, if the limit would exist there, it's going to be a removable discontinuity. If the limit doesn't exist, it will be non-removable. So let's look at it in a different way. So a removable discontinuity, basically, by definition, is one that can be removed by defining the function at a single point. So for this function, if I said, all right, we're going to redefine this function at 1, we're going to define it to be actually equal to 1. Basically, what I'm doing is I'm filling in the blank and making it continuous. So if you can do that, it's a removable discontinuity. It's still discontinuous, but we can remove it. So basically, it's just a hole in the graph. That's removable. Non-removable are those discontinuities that you can't do that. And there's two types you're going to see. One type of non-removable discontinuity is called a jump discontinuity. And the name is jump for a reason. If you see this function, and when you're tracing it, when you get to this point, you have to jump to this point to continue tracing it. So that's definitely a discontinuity, but it's non-removable because you can't redefine that for one point. And because it looks like there's a jump here, we're going to call it a jump discontinuity. So if I ask you, is the discontinuity removable or non-removable? If you say it's a jump, then you're right, because a jump is a non-removable discontinuity. The other type of discontinuity is infinite. Now that's also a non-removable. Can't remove that. And an infinite discontinuity basically is where a function would increase or decrease without bound, otherwise known as a vertical asymptote. So you definitely can't remove this discontinuity at 1 by redefining that point. You can't really connect those. So since you can't, it's a non-removable. More specifically, the type of non-removable it is infinite. So those are really common terms in calculus. They're important, I guess, because the AP exam covers them. I don't find them that important. The only thing you really need to know as far as that goes is that a removable discontinuity, you'd have a limit. A non-removable discontinuity, you would not have a limit. So let's get into the types of questions you might see. So I'm going to give you a series of functions, and I'm going to ask you to find the discontinuities, and if or if not, those are removable or non-removable. So we'll start with this one. When you're given an equation or function, to find out where it's not continuous, you want to find out where it's undefined, because that's definitely a non-continuous part of the graph. So when you have a rational function like this, you know a rational function is undefined when the denominator is 0. You have to find out where this is 0. The easiest way to do that is to factor it. So that would be factors of negative 32 that add up to 4 would be positive 8 and negative 4. Stop right here. Now you want to identify the discontinuities. Since this function is not defined at x equals negative 8 and x equals 4, because that's where the function is undefined, those are discontinuities. So we found the two discontinuities. Now we're going to determine which are removable. So a couple ways. If you remember from the last section, if we can factor out the x minus 4, that's just going to be an open circle in the graph, indicating that's removable. If you look at the bottom, x equals negative 8, that's going to give you a function where you have negative 12 up top over 0, which indicates a vertical asymptote, which means non-removable discontinuity. Better yet, just do this. I just removed 4 from the discontinuity. So this is removable just because of the cancellation. This is non-removable because it wouldn't cancel out. And more specifically, it's a infinite discontinuity. So that's all you have to do for a rational function. It gets a little more interesting with the piecewise functions. So I'm going to stop this video here. The next video will be dedicated to our piecewise functions.